And our next speaker, Muntis, is machine learning lab lead at Emergn, and he will tell about document and claim management in insurance industry. Please, Muntis.
Hello. So thank you, Aldis, for introduction. So today I'm gonna talk about intelligent document automation, and similar to our previous presentation, there are some similarities in that I think the MLI industry is more and more looking towards specific ways on how to use the technology. It's kind of getting more and now broadly adapted, and I think it's really interesting to focus more on like business cases, on exact usage, because other than mathematical problems, those are sometimes really difficult to identify. Yeah, I'm Muntis. I'm a lead data scientist at Emergn Machine Learning Lab. We work on a lot of different projects, and our team in specifically, we are focused on prototyping a new solution or product development really based or core enabled by machine learning technology. And today we're going to talk about what I call data or document communication, just so that you understand maybe the scope of this, about typical document lifecycle and automation of those. A case study or example on our use case, some of the pain points and intelligent automation possibilities there. So I'll start with the data communication. So with this, I understand like the touch points between clients or companies or services. So nowadays, if we're thinking about a company or like industry or maybe a government institution, the structure is somewhat similar. There's some kind of a company. A lot of the internal systems are IT related, and a lot of the internal data is like structured data. So you have like your services, your systems, you do your daily work, some data storage. Between the systems, there's direct integration, and everything is nice and working. The kind of next level of that is if you want to kind of go lower in how exposed the data is. There's like a services or sometimes external integrations with maybe a different kind of company data, or if you need to communicate. So my screen keeps disabling, so I might look back a bit. And then at the very lowest level, there is the external data communication, which is so if you contact like a medical institution or maybe something, some like public services or something, oftentimes you will be connected through emails or PDFs or some office documents, sometimes chatbots nowadays, and most of this data is unstructured or semi-structured. What does this mean? It means that it's most likely kind of easy to understand for a human, but from like a computer to read back these in the kind of other end is really difficult. And oftentimes, this is like the exact set of a company. But what happens if kind of there are multiple companies, for example, your medical institution or your insurance or something similar that communicates to you, but then you as a customer, you need to communicate back to another company. So you go back again on the kind of same stack of technology. You take the emails, you take the documents, you send them back. Then they have to, between their services, kind of enter this information back in, try to summarize it, try to extract the interesting bits for them, and then go back to the kind of in their internal systems to process what actually was there in the documents. And as you see, it's pretty inefficient. Of course, in ideal world, all of the companies would be communicating at their kind of internal or external integration level, but that's not really how the real world functions, sadly. About how the documents are getting processed. So if you go back there at the very bottom, or once the documents are coming in, they usually follow somewhat similar document processing steps, which is receive documents. Then you do some kind of a processing. Usually it's like a keying or data mapping, and then some kind of archiving. The problems with this are usually the same. The work is highly manual. It needs some decision making or understanding of the structure of internal documents. You need to understand the text sometimes, even if it's like predefined forms that you're entering, like your insurance, like for example, car insurance or something. Even then you have to kind of go through and understand, because those, as you know, different insurances will have different forms. So it's not always the same. So you have to manage through a lot of documents, and it's time consuming and it's difficult to scale. And at the end of the day, all of this is kind of trying to make data that was once structured but now is unstructured, going back to a more structured understanding. So if we kind of expand the middle bit a little bit, the data processing here in the middle is roughly in 3 or 4 different steps. We'll focus on the first one today, which is the metadata extraction, about how to automatically try to extract this data so that we don't have to go through this manual labor every time. There are different processing steps like document classification and routing, document anonymization. Previous year, I gave a talk about document classification and routing, so if you're interested, you can look it up. Let's now focus in on more exact case study about the insurance claim processing. They face really similar problems that I just discussed. It's one of our clients where I think we implemented a successful solution, so I'll show what I mean with that. So the pain points in the processing are somewhat similar to what discussed. Essentially, a claimant, after some kind of an incident, needs to prepare a bunch of forms, maybe has some insurance documents passed on him, has some medical documents or attorney documents, registration forms, some just what we call pack of documents that he needs to sign in to the claims processing. And there is a kind of middle company, like a lawyer firm, that's taking care of the case processing to the court. And then they face with the problems that I just discussed. Essentially, the information from each of these sources, like the medical one, the insurance one, the attorney one, comes from a system where the data was originally structured. But since it's now in kind of more paper or digital document format, they need to go back into those documents, they need to structure the data, they need to find the data sources. Sometimes they even need to go back to these third parties and kind of look up and validate the information. So they even need to kind of double check it through the external services. And all of this process is pretty difficult, takes a lot of time, and especially for a company that would kind of primarily focus on their lawyer work to help to process these cases, or found like fraud cases or potentials for like changes in amounts of money and things like that. You spend awful lot of time and even have dedicated teams that would do this process. And this kind of mapping, or sometimes called keying or rekeying process, in total, all of the insurance companies deal with this, and it's actually costing a lot of money across the industry. How the process happens internally within like a insurance company or like the claims processing company is that, as I mentioned, the claimant and other parties send in the document, a bunch of documents, like a document pack that has a lot of information. It has a lot of information that's not really needed but needs to be validated. For example, that the same person is across the documents, that the dates match, and all of the rules on top of that. But the data is unstructured or semi-structured. It has some valid bits somewhere, represented here by the colorful blocks, that are the valuable information needed for you in the system, but it has awful lot of other information as well. And the idea here is that if currently this is done completely manually, we can do algorithmic validation via utilizing AI and machine learning. We're able to extract the valid bits of the information and kind of map them to our source, to our target system. And then we can also add a lot of the extra things like rule-based checks or validation. We can integrate third-party services here as well to kind of immediately double-check some of the values and things like that. And afterwards, we can kind of way quicker go back to the core of the work, which was the lawyer work, to look into the insurance cases and actually process them properly. And currently, this middle bit in most of the industry is done like manually by a team dedicated to processing cases like this. And it's taking a lot of time, and it's difficult to scale. So we're proposing or have implemented a solution, as I mentioned, based on AI, machine learning, and intelligent automation to help with this processing. And since it's a really kind of cognitive, expensive task for a person to look and validate and not make human errors in this, it really helps and speeds up the process a lot. So behind the scenes, what's actually happening, of course, it's not magic or something like that. It needs some prep work done as well. So of course, beforehand, if you're processing these cases, we are targeting at not full automation. A lot of the tasks like this that have like documents or human written forms are difficult to 100% automate. We are thinking more about a mixed scenario where we're trying to automate the bits that make sense, but leave the kind of human in control of validation or changing or validating the, or slightly editing data afterwards if there are some mistakes or maybe there's something missing. So behind the scenes, there is a machine learning model. In this case, we are using the Microsoft form recognition model. It's a transfer learning model where you're able to, it's combining computer vision and OCR to identify parts of the documents, and then you're able to kind of train your own forms on top of it. So the idea is that a person who would normally be, for example, processing the claim documents can see like repeated patterns. Like he knows that the documents from this specific insurer always come in like this pack. He has these few forms always coming in. He can grab a bunch of forms. You don't even need that many examples. Feed it to the system, kind of show the system, okay, the expected values of interest are here, here, and here. You do the labeling in this form recognition tool. There are also other tools available in the industry which serves similar purpose. And then the kind of your end result of this is you have a model that's able to extract the information, and you're afterwards able to kind of map it to a tooling and to your target form. So I'm going to show you a couple screens of a tool we developed on top of this and kind of talk about how it improves, and we will see like a short demo afterwards as well. So this then at the end works as a service which we are able to feed in a claim like pack of documents, and you get your results immediately in your claims system. You can create customizable forms, create new forms, create new like attributes, add them to your target system. We originally developed this as our proprietary tool, but we've been working together with client to integrate it into his systems. And the idea is to not take away from the work that's usually done by the like this document processing team, but to empower them and improve their daily work and try to take the kind of mundane task and trying to automate the rudimentary bits. So here I will have a video. I hope it's playing. I'll kind of try to talk over it. Yeah, so this is a demo recorded from like really early alpha by my colleague. The idea is that this tooling is mapped to, for example, your emailing system, to your specific folder, where you're able to get new claims cases coming in with like pack of documents. And then when it comes in, it automatically gets ingested by the system. It automatically applies the machine learning models behind it, and afterwards you see, if you open the claims system, you see your kind of claims coming in with their attached documents and things like that. This can be integrated in any kind of already existing claims system that you are using, and you can see that. And then the kind of key concept of this is that you can define your expected values or expected attributes. You throw a bunch of documents of it towards it, and since you've trained on what's the important information in these documents, you're able to look it up, and it's automatically recognized where it is in these documents and validated. You can cross-check if the information is correct. The idea here is that the form on the left side is kind of pre-filled of the values that you would want it to be, so you don't have to dig through like tens of documents, but it's automatically looked up. Also, if the values doesn't match exactly, then you'll get like a notified or like an alert message that, for example, the surnames are sometimes different, or the phone number doesn't match, or like the policy number is different between the forums. So it might even be like a fraud case or just a human error. So this really helps to speed up the claims processing, and after you kind of go through with it, you can just save it, and you can integrate with your existing claims processing systems to kind of directly register a new case. So this really speeds up the digging through documents and data extraction, and really speeds up this part of the business. So the total benefits of this is, as I mentioned, you really speed up the processing time from like a few hours to like a day, for example, to process these new cases to like a few minutes. You also don't need as big of a support team to support your like legal team that's actually investigating the contents of these claims. And you can reduce the time for like processing a case to like way lower than before. So you can also improve your like times of response to the clients. Maybe something's sent in, you can respond really quickly because the kind of end-to-end process is way lower. And since this is like a complete solution built for this, actually adapting it to new forms or to new target systems or to new documents is really quickly. And the idea behind this is that the company would benefit from this the most if they could both define what are the values expected. They could both attach new forms, so you don't need to be like an expert in data science or machine learning, but using these pre-existing tools, you can define new ways and try to automate, and also implement like low-code automation just to directly be integrated in your emailing, for example, and things like that. So that's all I have for you today. If there are any questions.
Yeah, thank you, Muntis. If you have a question, just raise your hand and I will come with mic. So, Muntis, you showed that it works with like many incoming documents, and in claims process, probably there are many different documents. So how much time it takes if there is a new document and I need to train it for the system? So how much time it takes and how much samples I need?
Yeah, so thanks for the question. This is slightly different across different kind of these pre-trained models or services that provide this. We are using the Microsoft, for example, in this exact scenario, like the Microsoft Form Recognizer. The minimum amount of examples is really just 6. So you have 6 documents of like the same kind. You put them to the system, you apply the labeling, and it's able to recognize them. And it's actually pretty robust. If there are some changes to this, like different number of pages, or maybe there's like an extra field or two appearing in the form, it shouldn't need to be updated immediately. It's pretty smart, so it works well. Of course, for like more complex scenarios, it would be better to add more examples, but it's actually really fast and really easy and doesn't require technical knowledge. It has a UI, you can go in, do like the labeling with like your mouse and keyboard, and it's fast and done. Thanks.
Yeah, and okay, and you also mentioned that this is pre-trained AI, right? It is a ready service from Microsoft. So if I, for example, I need own model that is running probably on my training data or on my premise, what effort it takes?
So of course, thanks for the question. This is different case by case. In our example, we are utilizing this, but our solution that we've developed is based on microservice architecture, so you can pretty much take any model that you have trained that returns like a standardized locations like coordinates within the documents and labeling where it is, and you can kind of match it to your own backend, if you will. So if you have a different kind of model, maybe in-house custom developed that does this recognition, you can map it as a service, like through an integration level, and it's all possible. Yeah.
And in your example, it's applied to claims, like claims automation. Do you see any other use cases where it could be the same principle used?
Yeah, we are already in talks with a bunch of clients that are also facing similar problems. So like claims, of course, like insurance, some payment where you need to like invoices and need to pay bills, and a bunch of others as well.
Okay. So, any other questions? Seems no. So then, thank you, Muntis. Thanks.